Hey, what's going on? It is your boy Jay Bailey here, and I'm back with yet another video. Before I get started, shout out to my man Godzilla. Yes, this is my little Godzilla figurine here. He showed King Kong who is boss, and I cannot be more happy for him. If you haven't seen Godzilla vs. Kong, I urge you to go and watch it. It is pretty epic. All right, so he's gonna be watching us do this challenge today. So he's just gonna sit right there where he can see and enforce his awesomeness on us. All right. So we've seen challenges from this author before, this destructor guy, and the only description he gives us is the tip. It says float, and this challenge, as you might imagine, it introduces us to floating point instructions. So we're gonna see what these SimD instructions look like. Spoiler alert: they look pretty gross. They're pretty confusing sometimes. Well, that's not totally true. They don't look that bad, and once you kind of get used to them, they're not terrible, but they're pretty gross. Anyways, let's go ahead and get started. So we see that the binary we have is called float.bin. Maybe that's float in some other language. I don't know what that language that is, but anyways, let's go ahead and run file on there, and we see that this is a 64-bit binary. It's dynamically linked, and we see that it's not stripped. So we love to see binaries that aren't stripped, right? So we can go ahead and look at the symbols and see if there's anything interesting in there. The main function there, we see scanf being used. Nothing too interesting there. Let's go ahead and look at the strings before we open this up in Ghidra. Alright, and again, not much interesting going on, but we do see bad password, we see good password. Obviously we want to pronounce the good password, we don't want to pronounce the bad one. So let's see, let's just go ahead and open this up in Ghidra because we don't really know what's going on. And before I do that, I'm going to open up this sudo.c. Alright. And now let's open this up in Ghidra. Alright, so let's go ahead and jump to the main function here. And right away we see these SimD instructions or SSEE instructions. So something to note here is that we see that this variable here, this dat memory address there, is going to store it into this XMM0 register, and that is a register that holds floating point values. So, and I literally just learned this trick like as I was rehearsing for this video. I just learned this trick like right now. So this is pretty cool. Watch this. So on here we see that this is the hex value that's being stored in this register here, and it looks like it's a really big value, but since this is a floating point number, it's actually not that big. So let's go ahead and take a look here. If we double click on that value, we see that Ghidra said that this is an undefined value here, but we can change the data type though. So if we right click on here and go to the data here, and we can see we can change to float, and that's gonna change it to see that we now see the actual value is 3.564. That is really, really cool. That's really awesome. It's gonna make it a lot easier to sort of keep track of what's going on. So we see that this 3.564 gets stored into this XMM0 register, and that gets stored into this variable here. So let's go ahead and rename that to, let's just say num1 underscore 3.564, just so we can keep track of what these values are. And in our sudo c, we're going to say num1. Actually, we're also going to, in our sudo c, I don't normally do this, but I'm going to keep track of the actual data types because they're going to change the route. We're not going to deal with only floats. There are going to be some integer values in there, which makes it a little bit confusing. So I'm going to keep track of that. All right. And here we see that we're going to get our user input here, right? We see we're going to we're loading this up into the value registers, and this one here, the format specifier is %d. So our user input is not going to be a floating point number. So it's actually going to be a decimal, right? So we're going to load that up in there, and I'm just gonna go ahead and call it a int user input, just so we can again remember that this is an integer, not a floating point number. All right, and then we see that we're going to take this local C variable. Oh, sorry, that's our user input. Let's let me rename it to user input. All right, so user input there, and then we're going to zero out this register, and we're going to store our user input into this. All right, so this is another instruction here that's kind of confusing. CVTSI2SS. It looks very disgusting, but all that's doing is going to convert our user input into a floating point number, right? Because so if we typed in 5, it's going to print that to 5.0. All right, and so then we're going to add these numbers together, and then we're going to store the result into this this variable here. And again, recall, so this variable that so after we add the two numbers together, right? So it's gonna be 5.0 plus 3.564. It's gonna be converted to a regular integer number, because this local 18 is not going to be a floating point number. It's gonna be an integer. So what I'm gonna do here, I'm just gonna say int. I'll just call it result, if I can spell it. And it's gonna result is going to be equal to num1 underscore 3.564 plus user input, which in this case is being casted to a float, right? So let's just assume that we typed in 5 here. It's going to be 5.0 plus 3.564, which again, since we're storing this into an integer, we're going to lose that precision, so it's going to be 8, and that gets stored in there. And then we see this P XOR. I kind of skipped it up here, but P XOR, it just XORs two floating these XMM0 registers, and when you XOR two registers, the same register together, it just sets it to 0. So this here is essentially setting this variable here to 0, and then we see there's an unconditional jump, and so we're going to assume this is going to be like an I variable there. So that's essentially saying I equals to 0. But remember, since this is a floating point register, this I is actually going to be a floating point number, which I'm not sure why they're using I as a floating point number, but that's what they're doing. And jump down here, and then we see again we're going to, let's see, this local 18 variable. Wait, did we already? Oh, okay, so there's a local 18 variable, sorry about that. Let's see, we're loading that into this register here, and then we're going to compare it to, wait a second. Oh, that's right. Okay, this is the result here. Sorry about that. All right, that's why I'm getting a little confused. Okay, so our result is going to be compared to I, and this uCommas here is comparing two floating point registers or numbers. So it's going to be while result is greater than I, we're going to do some stuff. And I say greater than because we see there's this JA, which is jump if above. So we're going to, so that means if this result is greater than I, we're going to jump back up here. And let's see what's going on here. All right, so now we're going to take the result, and again we're going to convert it to a floating point number. So whatever that is, like it's going to be 8.0 in our example, right? And then we're going to store I. We're going to add I. This add SS and just adds two floating point numbers. We're going to add that to result. So right now we have result plus I, and then we're going to store this local C. This is a new variable here. Just put that into this XMM1 register, and then we add that to the previous result plus I. So we're going to just say we'll name this just num here. I'm not sure what to call it there, but it's just going to be num, which is probably a bad name for it, but I can't think of another name. And then let's see, we're going to then we're going to store the result of that into num, right? So what that looks like is going to be num equals to result plus I plus num. All right, still with me, right? Okay. And then what happens here? So we see we set that to XMM1 register again, and now this is another example here. So this memory address here, this DAT 100 AB8 holds this 3F4CCCD in hex. And again, since we know this is going to be a floating point number, we're just going to double click on this, and we're going to retype this to a float here. And we see that's 0.8. So let's go back here. And so what's going to happen here is we're going to say we're going to add I, which was in an XMM1 register, to this 0.8 value here, and we're going to store that back into I. So it's pretty much going to be I plus equals 0.8. And I guess that's why they chose to do I as a floating point number, so they can do this incremental I plus equals 8.8, and not, you know, we normally see like plus equals 1, 2, or some things like that, but they chose to do 0.8. And that's all that's going on in this loop here. And so after it breaks out, it's just gonna print out. It's gonna take the result of this, right? So this is gonna end. It's gonna take that number, store it into a floating point register, and then it's going to print out the number as an integer or as a floating point number. So it's going to look like something like this: printf %f num. And so that's pretty nice. So like after it does this calculation, it's going to pretty much print out what it calculated, and then we see that it's going to then compare it with this number here, right? So we go down here, nums gets again put into this xmm0 register, and that gets compared to this dat 108bc. But again, if we double click on there, we can go ahead and retype this to a float because we know what the type is. And there it is. So it's going to compare our result to 4,550.8. And so JP here, it says jump if that means jump if the parity flag is set. So what's going to happen here? The uCommiss instruction, it sets various flags. So there's greater than, equal to, less than, and there's unordered as well. And if the parity flag isn't set, I guess that's the flag that says they're equal to each other. If it's not set, that means it's a bad password. If they are set, that means it's a good password. So pretty much if num equals to 4550.8, then it's going to say printf good password and return 0. Otherwise printf bad password, and then I guess return 0 as well. All right, so that's pretty much it for this entire function, right? So we have to pretty much insert a number that when it goes through this little calculation here, it's going to be equal to 4,550.8. Now I'm a little embarrassed by this. I had to guess what the magic number was. I really didn't know how to mathematically solve it. I should be able to solve it because it looks like a pretty simple equation, but for some reason I just couldn't get it to work. So what I just did some brute forcing. So I just tried 40, and as I told you earlier, it prints out the result here. So that's obviously not, that's less than what we wanted to. So we're going to go ahead and try it again. We're going to try, let's just say 45, and it's still a little bit less, but then we do 46, and there it is, good password. So that's what it is. I'm a little upset that I couldn't figure out why the 46 is the magic number. If anybody knows why 46 is the magic number, let me know in the comment section below. I would love to hear that explanation, but I couldn't figure it out. Even though I have a math degree, my math skills aren't that great. As you can see, I'm a little bit embarrassed about that, but it's okay. It's okay. I mean, the main thing is we figured out exactly what's going on, so I think that's a little bit more important than figuring out the math there. I'm just trying to make myself feel better, but okay, guys. Anyways, that's all I have for this video. If you liked it, you learned something new, give me a like. I really appreciate that. If you have any questions, if anything was unclear, let me know in the comment section below. I'm usually pretty quick to answer any comments people have. Yeah, so if you have any questions, let me know. If you have any challenges you would like me to try next, also leave that in the comment section below. I'd love to try new challenges. I'm not that great, so it may take me a while to solve some of them if they're like really hard, but yeah, I'll give it a shot, and then eventually I will post a video on it. But that's about it. If you like this video, you want to see more of this type of content, do not forget to subscribe and hit the bell icon so notified when new videos go live. See you guys in the next one. Me and Godzilla saying peace out.